Okay, let's dive right into this explainer. Welcome to the trading floor. Now, you might be wondering, why on earth do we call it that? Well, think about it. Stepping into a Cambridge computer science exam is literally exactly like stepping onto a high-stakes, incredibly intense financial trading floor. The clock is ticking relentlessly, the pressure in the room is absolutely immense, and every single second you spend writing needs to yield the maximum possible return on investment. You are, quite literally, trading your precious time for marks. And listen, right now, a huge majority of you are making really, really bad trades. You're investing 5, maybe even 10 minutes into a massive paragraph that's only ever going to pay out one single mark. It's a terrible return on investment. Today, we are completely changing that. We're doing an examiner's masterclass on split-second exam decisions, and we are going to anchor this entire strategy using a real, authentic Cambridge syllabus past paper specifically focused on bitmap images. And look, whether you are sitting syllabus 0478, 0417, 2210, or 9618, it doesn't matter. The absolute rules of the trading floor apply to every single one of you. We are going to completely overhaul how you process information under extreme pressure, taking the raw, basic data you memorized from the syllabus and turning it into a precision instrument that extracts the maximum amount of marks. So, let's get to work.
We've got a seriously packed agenda for this session. First up, the challenge. Second, the strategy reveal. Third, the transformation. Fourth, an interactive workshop. And finally, the final system. Let's jump in.
Section 1. The challenge. Why good memory fails. I want you to imagine a very realistic digital scenario for a second. Let's say a massive retail warehouse urgently needs a brand new facial recognition security system at their main employee doors. The exam explicitly asks you to evaluate the use of high-resolution bitmap images for this exact specific purpose. Now, this is where standard rote memorization falls completely flat. Consider two very different students facing this exact same question. First, we have Alex. Now, Alex is that student who has a genuinely great memory. Alex sees the word bitmap and immediately starts writing a massive, overwhelming block of text. We're talking definitions of pixels, intricate details about color depth, full-blown file size calculation formulas. Alex's hand is physically cramping from writing so much. And honestly, to an untrained eye, it looks like an incredible, highly detailed answer. But then the examiner's red pen comes out and it strikes through almost all of it. 0 marks for application. Why? Because Alex completely overloaded the answer with raw, isolated computer science facts, but totally ignored the actual facial recognition security scenario at the warehouse. Then, on the other end of the spectrum, we have Sam. Sam looks at the clock, completely panics, and rushes. Sam writes that bitmaps are good because they show high-quality pictures of faces to keep the warehouse safe. The red pen strikes again. Sam totally missed the actual command word requirement, gave a supposed advantage with absolutely no underlying technical reason, and completely failed to explain the actual digital process. So Alex wrote totally isolated theory, and Sam wrote incredibly vague assumptions. Both of them are completely bankrupt on the exam trading floor.
The absolute most crucial point here is captured perfectly in the examiner's own methodology. They state, generic responses rarely gain full marks. Anchor your explanation to the details provided. I really need you to hear this. Cambridge examiners absolutely do not reward you for writing short, generic, copy-pasted textbook labels. They really don't care that you know what a pixel is in a vacuum. I mean, they absolutely want to see precise terminology for sure, but they explicitly demand that you explain the underlying process clearly, that you compare it to alternatives, and crucially, this is the game changer, that you connect that theoretical explanation straight back to the specific scenario given in the prompt. It's like if the context is a busy school network, your answer literally must breathe the air of a school network. If the context is an automated industrial robot arm, your answer must be bolted to that exact robot. You absolutely must anchor your knowledge to the reality of the question.
Section 2. The strategy reveal. Decoding the demand.
Okay, so how do we avoid the massive traps that Alex and Sam fell straight into? Well, you have to decode the specific demand of the question before you pick up your pen to write a single word. Top-tier students use this precise methodology of specificity, which perfectly mirrors a framework you might already know, the Peel framework. Let's completely break down this 4-step sequence because this is where the magic happens. Step 1. Identify the task requirement. Ask yourself, what is the exact command word here? Is it describe? Is it evaluate? Or is it compare? Those words demand totally different responses. Step 2. Classify. What specific digital data, hardware, or process are we actually dealing with in the prompt? Step 3. Explain the sequence. How does the technical process truly work, step by step, in such a clear way that even a complete beginner could follow the logic? And finally, step 4.
Connect to context. This is the link part in the Peel framework. Point, evidence, explanation, link. You have to actively loop your highly technical explanation right back to the practical consequence for the actual user, the system, or the organization that was mentioned in the exam prompt. This specific framework forces you to build an unbreakable bridge between abstract computer science theory and real-world digital problems.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's apply this incredibly powerful strategy to our actual topic. The theoretical foundations of concepts like bitmap images very often depend heavily on distinguishing them from other nearby concepts. The source material highlights that critical mistakes frequently arise when learners confuse similar things, like confusing memory with storage or confusing logic processing with arithmetic processing. To truly prove your deep, unshakable understanding to a Cambridge examiner, you need to define a bitmap by explicitly contrasting it. Don't just say it's a basic grid of pixels. That's a middle school answer. Contrast it directly with vector graphics to show that you genuinely understand exactly why a bitmap is chosen for continuous tone photographs in a complex website, rather than using a scalable vector. Contrasting your answers shows real mastery. It proves to the examiner that you aren't just blindly reciting a dictionary definition, you are actively making a calculated engineering choice.
All right, it is time to put you on the clock. Let's see how sharp you are. You have exactly 30 seconds to spot the model method that correctly diagnoses the exam demand. Imagine we have an industrial control scenario where a robotic arm uses high-speed cameras for quality assurance on a fast-moving assembly line. Which of the potential answers perfectly follows the Peel framework? Think it through. Does it make a clear point about the bitmap? Does it provide solid evidence of the technical specification involved? Does it offer a clear explanation of the internal processing? And crucially, the biggest piece, does it link all of that right back to the robot checking for physical manufacturing defects? Take a moment. Mentally scan the options. You need to find the one that doesn't just list a bunch of dry facts, but actively, dynamically solves the digital problem presented in the manufacturing scenario.
Section 3. The transformation. Red pens to green checks.
Now, this is exactly where the theory hits the road and becomes real marks. Notice how quickly all those terrifying red pen marks completely vanish when we stop being vague and start being precise. Let's look at an original, deeply flawed answer. The retail store should use bitmaps because the camera takes pictures of barcodes to sell things faster. Ouch. Red pen everywhere. Why? Because it names a device, a camera, but it explains literally nothing about the actual computer science. It gives a broad advantage, selling things faster, but with absolutely no technical reason behind it. Now, let's completely reconstruct this into a context-specific Peel paragraph. Listen to the difference here. The retail store's barcode scanner captures a bitmap image of the product code. That's our point. The specific image is comprised of a tight grid of black and white pixels represented internally by binary ones and zeros. There's our evidence. The system's logic processing then compares this specific binary pattern against the massive product database to instantly identify the item. That's the explanation. This exact bit-for-bit comparison allows the retail system to instantly retrieve the correct price, significantly speeding up the checkout process for the customer. And boom, there is our link. Green checks across the entire board. Do you see what we did? We totally rebuilt the answer around the specific retail system scenario, explaining the hidden, underlying mechanics step by step.
So how do you practically guarantee that you can execute that kind of transformation live in the exam room when the pressure is on? You do it by internalizing this incredibly reliable 4-step memory structure. Step 1, what is it? You must clearly define the technical concept. Step 2, how does it work? You have to explain the underlying mechanism or the exact sequence of technical events. Step 3, where is it used? Identify the specific hardware, the software, or the exact scenario context from the question. And here is the absolutely crucial jump. Step 4, why is it used? State the concrete, practical consequence or the clear advantage over an alternative method. This 4-step structure is your safety net. It guarantees that you never accidentally skip from basic recognition straight to application without firmly securing the underlying technical explanation first. Because listen to me, if you just jump straight to why it is used without ever bothering to explain how it works, you are leaving a massive amount of marks sitting right there on the table.
Section 4. Interactive Workshop Split-Second Decisions. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries.
Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, for your first interactive challenge today, you have exactly 60 seconds on the clock. We can take Bitmap image characteristics, things like color depth, overall resolution, and different compression types, and we can map those directly to practical consequences for actual users across totally different digital scenarios, like complex websites, massive databases, and highly secure communications. Your job right now is to mentally scan this data source and extract the core underlying trend that connects the raw hardware selection directly to its practical consequence. Seriously, don't just passively read the boxes on the screen. Actively look for the relationship. How does a massive increase in color depth directly, measurably impact the load time of an e-commerce website over a standard, potentially slow mobile network? And how does that technical change fundamentally alter the end user's experience? The Cambridge exam is absolutely never going to ask you to just blindly recite a table. It will demand that you synthesize it. You have to find that critical pivot point where the pure technical specification directly alters the real-world outcome. All right, time for challenge number 2. I need you to diagnose the fatal flaw here. Read this highly typical, very flawed sample paragraph with me. A bitmap image is made of pixels. This is good for the school network because it shows pictures. Take a second. I want you to identify the exact sentence that is just absolutely hemorrhaging potential marks due to incredibly vague wording. I will tell you right now, this kind of answer might, on a good day, scrape one single mark for using the word pixels, but it fails the critical application test completely. Why is it failing so badly? It clearly mentions the school network, so you can see the student tried to use the context. But what is the absolute critical missing piece of the puzzle here? Look really closely at the specific phrasing. Good for the school network because it shows pictures.
Let's reveal the answer. Here is the actual examiner commentary revealing exactly why that specific student lost almost all their marks. The students successfully named the broad concept, but they utterly, completely failed to explain how it actually functions deep inside the school network scenario. Notice the absolute classic wrong turns highlighted here on the screen. Fails to explain how the process works. Let's be real. Saying it shows pictures is a layman's description. It is not computer science at an exam level. Think about the real questions here. Does the school network need to heavily compress these bitmaps to save limited bandwidth? Are these images being stored long-term on a central server, or are they temporary? Are they being transmitted constantly across a local area network? The answer misses literally all of the crucial process steps and completely lacks true real-world contextual transfer. It is a wildly superficial link, and I promise you, examiners see right through it in a heartbeat.
Okay, challenge 3. This is the ultimate test of everything we've covered. You now have exactly 30 seconds on the clock. I want you to mentally speedwrite one absolutely perfect peel paragraph, evaluating a security method that utilizes bitmap images. Let's raise the stakes. Imagine a highly advanced biometric fingerprint scanner at the entrance to a major bank vault. Ready? Go. Point, evidence, explanation, link. Do not just tell me that it's secure. You need to explain exactly how the scanner physically captures the bitmap of the fingerprint, how that resulting binary data is actively processed by the system, and why that specific, exact data representation fundamentally prevents unauthorized access to the vault. 30 seconds to prove you can apply the full framework under extreme pressure.
Time is officially up. Take a breath. Let's move to Section 5, the final system.
We are taking absolutely everything we've learned today and synthesizing it into the ultimate exam cheat sheet. You've clearly seen why simple memory fails under pressure, you've learnt the methodology of specificity, and you've seen exactly how to transform vague, weak answers into top-tier responses. These 3 specific rules are your absolute guarantee for top marks on the Cambridge computer science papers. Rule number 1. Command word decoding. You absolutely must never start writing until you know exactly, precisely what the examiner is asking you to do. Diagnose the demand first. Rule number 2. Peel framework application. Application first is literally the only way to write. Point, evidence, explanation, link. You have to anchor every single technical fact you know to the scenario provided, whether it's an e-commerce website, a school network, or an embedded system. Rule number 3, the time management matrix. You have to match your physical writing effort to the actual mark allocation. If it's a simple 1-mark question, give a fast, precise definition and move on. But if it's a massive 8-mark evaluation, you absolutely need a full, robust peel structure with deep comparisons and rich context. You must invest your time where the marks are highest.
Now, the source material perfectly outlines exactly how you should prepare before you ever set foot in the exam room with the highly effective 3-pass revision cycle. Pass 1. You need to completely secure your core definitions and your contrasts. You need to truly, deeply understand the fundamental difference between memory and storage, or between a compiler and an interpreter. Pass 2. Rehearse your work to explanations and your structures. Practice physically drawing out the diagrams and writing out the complex, step-by-step logic sequences until they are absolute second nature to you. And Pass 3. Focus heavily on exam adaptability. Listen, this is the absolutely crucial step that almost most students completely skip. You must actively practice changing the scenario. Take a great answer you wrote about a school network and physically force yourself to rewrite that exact same concept for an automated industrial control system. Mix similar terms together and force yourself to strongly justify your engineering choices.
Take a really close look at this breakdown because it visually represents exactly where students massively hemorrhage marks every single year. A staggering 45% of marks are lost simply to vague, imprecise wording. Another 30% are lost entirely due to missing the required context. Think about that for a second. You can completely conquer 75% of your typical exam errors simply by forcing yourself to be specific and actively anchoring your knowledge to the given scenario. Students who implement these exact computer science strategies see an average improvement of 2 full grade boundaries. That is massive. But, and this is a really massive but, that only happens if you practice consistently. You have to actively avoid these classic wrong turns with our weekly videos. You have to train the system until it becomes an absolute reflex.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS, to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your exact target grade for computer science and tell us the absolute biggest challenge you're currently facing that's keeping you from hitting it. Our incredible team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep practicing, keep analyzing those past papers, and go absolutely ace those exams.